Semester Exam Review Packet, page number 3. So, use the diagram below to answer the following questions. Find the distance from point M to point N. From M to N. And so I'm trying to find out how long is this segment. N has coordinates -3, +2. M has the coordinates -6, 0. So to find the distance, I want to use the distance formula. So I want to take the square root, and now I'm going to take one of the x coordinates minus the other x coordinate squared, plus one of the y coordinates minus the other y coordinate squared. And so we do inside the parentheses first. -6 minus -3 becomes -6 plus 3. That is squared. And then 0 minus 2 is -2 squared. Now I want to make sure that when I square these numbers that I get positive answers. -3 times -3 is +9. -2 times -2 is +4. And 9 plus 4 is 13. So the distance is the square root of 13, or typing that into the calculator, it is approximately 3.605, so it rounds up to 3.61. Question 2 says find NP. So from N to P, this notation doesn't have any segment bar on top of it. This is referring to the length of NP, or the distance from N to P. So NP is asking the same thing as what we just did in number 1, except for these 2 points. The point P is at 3, -2. So I'm going to set up the square root and take the y coordinate x coordinate -3 minus the x coordinate +3 squared, plus the y coordinate +2 minus the y coordinate -2 squared. -3 minus 3, so do inside the square root first. That gives me -6 squared, plus 2 minus -2 becomes 2 plus 2, 4 squared. -6 squared gives me a +36, -6 times -6. 4 squared is 16, and 36 plus 16 is 52. So it is the square root of 52. If I type that in the calculator, 7.211, so it is approximately 7.21. We could also simplify that square root. Let's see, this could break into square root of 4 times square root of 13, which would mean it's 2 square root of 13 as one more option for the answer. Right. Question number 3 asks, what is the midpoint of MP? Plot this point and label it Q. So the midpoint of MP, so again I'm going to use my ruler here, and just to see, MP, so I need what's about halfway across, somewhere around -2, -1. But let's use the midpoint formula. So the midpoint formula takes the x-coordinate, -6, plus the x-coordinate of p, +3, and then divides that number by 2. And we do the same thing with the y-coordinates. The y-coordinate of m is 0, plus the y-coordinate of p, which is -2, divide that by 2. -6 plus 3 is -3, divide by 2. 0 plus -2 is -2, divide by 2. So the midpoint, -3 divided by 2 is -1.5, or we can leave it as a fraction, -3/2. -2 divided by 2 is -1. -1.5, -1, and we are to label that point as Q. Number 4, plot point R so that nr equals 5. What are the coordinates of R? So there's a variety of ways that I can do this, and R needs to equal 5. The simplest way is if I have n here, I need 5 units away from it. So I could go 1, 2, 3, 4, 5 units away and say that's my point R. It's 5 spaces, 5 units. So the coordinates of R, 2, 2. Now there's lots of different options here. I could have counted down 5 units, 1, 2, 3, 4, 5, and said -3, -3. I could count up 5 units, 1, 2, 3, 4, 5, -3, 7. I could go to the left 5 units. And if you may remember that a right triangle with sides 3 and 4, I could go to the right 3 and up 4, or the right 4 and up 3. There's lots of points that R could be. We just need to plot a point R so that nr equals 5, which we've done. Question number 5. Given A is the point -5, -6, plot it on your coordinate plane and find the midpoint of PA. So I'm going to plot the point -5, -6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So that is the point A. And now I want to find the midpoint of PA. So the middle of PA looks like somewhere around -1, -4. So let's use the coordinates for A and P to find the midpoint. So I want to take the x-coordinates and add them together. So -5 plus +3 are the x-coordinates of P and A. Divide that by 2. Take the y-coordinates, -6 plus -2, divide those by 2. -5 plus 3 is -2, divide by 2. -6 plus -2 is -8, divide by 2. And so the midpoint is -1 and -4, dividing each of those numbers by 2. find the value of the variables in the diagrams. So when I see diagrams, I'm looking for expressions that use the same variable, and so I can't combine x and y until I know what x is. So I would need to combine the 3x plus 8 with the x. Those are next to each other. They make a linear pair. So 3x plus 8 plus x needs to equal 180. 3x plus x is 4x. Subtract the 8 from the other side. Divide by 4. And x equals 43. So now that I know what x equals, x with 2y plus 17, they make a linear pair. So that means the 43 plus 2y plus 17 needs to equal 180. So 2y, if I add the 43 and 17 together, that is 60. Subtract 60 from 180 to get 120. And then divide by 2 to find that y has to be 60. X equals 43, y equals 60. Okay, go to the problem next to it. See, the top two expressions have x, this bottom right has a y, so I got to combine the x's together first. So that means that the 2x, find the edge here, the 2x plus 8 plus the 3x plus 17 needs to equal 180. 2x plus 3x is 5x. 8 plus 17 is 25. Equals 180. Subtract the 25 from both sides is 155. Divide both sides by 5. X equals 31. So now that I know that x is 31, I can insert that into either one of these expressions. And I like the vertical angle relationship a little bit better. So I'm going to take the 2 times 31 plus 8, and that needs to equal the 5y plus 15. 2 times 31 plus 8 is the value of the one angle, and that's the vertical angle with 5y plus 15, so they need to equal each other. 2 times 31 is 62, plus 8 is 70, equals the 5y plus 15. So I subtract 15 to get 55, divide by 5 to find that y equals 11. The next one, I have one expression with x and one expression with y. So you can use vertical angles or linear pairs. I'm going to use the vertical angles for the 2x plus 40 that needs to equal 110. 2x plus 40 equals 110. Subtract 40 to get 70, divide by 2, x equals 35. Y plus 20 is a vertical angle with 70. So y plus 20 needs to equal 70. Subtract 20 from both sides, and y equals 50. Next one over. Again, there's only one x and one y. In this case, since y is by itself, is not part of an expression, I'm going to use the linear pair, y with 75, and I know that y plus 75 needs to equal 180. If I subtract 75 from 180, y equals 105. 2x minus 5, it makes a linear pair with 75, or it's a vertical angle with y, which we now know is 105. And so I'm going to use the vertical angle relationship to say 2x minus 5 needs to equal the y value 105. So if I add 5 to the other side, 110 divided by 2, x equals 55. In the bottom 4 diagrams, I noticed that all 4 of these diagrams have the lines marked as parallel with these little triangle pairs, and so because of that, I know all my angle relationships should work in these situations. So 7x plus 8 and 22x minus 2, those two angles are on the same side of the transversal, interior of the two lines, so they are supplementary. 7x plus 8 plus 22x minus 2 needs to equal 180. 7x plus 22x is 29x. 8 minus 2 is 6. So if I subtract 6, find that 29x equals 174. I'm going to grab my calculator, say 174 divided by 29 equals 6. The next one, 6x plus 2 and 50 degrees, those are both in the upper right corner of the intersections, and so they are in corresponding positions. So I know 6x plus 2 has to equal 50 degrees. Subtract 2 to get 48, divide by 6, x equals 8. On the bottom, 130 and 17x plus 11. Those two are on alternate sides, but they're both on the interior of the parallel lines. The alternate interior angles are congruent to each other. So 17x plus 11 must equal 130. Subtract 11 to get 119. Then I'll take my calculator, 119 divided by 17, x equals 7. And the last one on this page, 95 degrees and 15x plus 5, they are on alternate sides of the transversal, but both on the exterior of the parallel lines. Alternate exterior angles are congruent. So 15x plus 5 equals 95 degrees. Subtract 5 to get 90. 90 divided by 15 leaves us with x equals 6.